For someone without the knowledge of operator precedence, it can be difficult in identifying the standard result while evaluating a mathematical expression like this. Multiplication has a higher priority in this expression, so the evaluated result would be 42. Same is the case with regular expressions. In the context of theory of computation, a regular expression can represent languages which are basically a set of strings using a simple but powerful set of operations: union, concatenation, and star. You could add more operations to your regex toolbox, but they all can be derived from these three fundamental regular operations. If you're a fan of the command line of Unix, you would already be familiar with the regular expressions which can identify patterns. Regular expressions are used in all major programming languages, especially while dealing with strings. Let me formally introduce you to the definition of concatenation of two languages. Given two languages L1 and L2, we define their concatenation to be the language L1.L2, which is xy such that x belongs to L1 and then y belongs to L2. Here is an intuitive example with L1 containing strings 0, 0 and 1, 0, L2 containing 0 and 1. The concatenation language L1.L2 will have the strings 0, 0, 0, 1, 0, 0, 0, 0, 1 and 1, 0, 1. It can be seen that concatenating a language with a language containing only empty string will result in the same language. Concatenation with empty set might seem a little counterintuitive. Concatenation with nothing ends up in nothing by definition. You can think of this as a multiplication with a 0, whereas a concatenation with empty string as multiplication with 1. With that knowledge, we can discuss about the inductive definition of L to the power n. The base case for this is L to the power 0, which is the language containing empty string. Just the way a number to the power 0 equals to 1 in the context of languages, language to the power 0 is the set containing empty string. Hence, L to the power I is the concatenation of I number of copies of the language L. If L is a language containing 0 and 1, L to the power 0 is a set containing empty string. L to the power 2 is the set containing 0, 0, 0, 1, 1, 0, 1, 1. And L star is the set of all binary strings, including the empty string. Formally, the star operator is the union of the powers of the language starting with 0 till infinity. By the look of it, you might think L star will always contain infinite strings in it, but we have two exceptions to this statement. The first one is that the star operator of an empty set results in the language containing empty string. You can treat this as a standard definition. The other exception is star operator on language containing empty string is language containing empty string. With this background, I can introduce you to the formal inductive definition of regular expressions. Here is the table that lists the syntax we'll be using in regular expressions and what they refer to literally. Phi refers to the language containing no elements. Epsilon refers to the language containing the empty string. A corresponds to the language containing the character A. That's the beauty of inductive definition. Just with these three bases, we'll be able to build all the regular expressions out there using the three regular operations, union, concatenation, and star. Let me walk you through few basic regular expressions. 0 union 1 would be the language containing only 0 union the language containing only 1, which would be the language containing 0 and 1, which is basically the alphabet sigma. For representing concatenation in regular expressions, we usually avoid using dot or circle operator. We write it this way. Like 0, 1 is equivalent to 0 circle 1, which is the concatenation of language containing 0 and language containing 1, which is the language containing the only string 0, 1. And then 0 star is basically the star operator on the language containing the character 0, which would be that. And finally, I'd like to highlight the usage of parentheses in regular expressions. So here we're trying to evaluate 0 union 1 first and then apply the star operator. And that would result in 0, 1 whole star, which is basically sigma star. When there are no parentheses in your regular expression, the operator precedence kicks in. In regular expressions, star has the highest precedence, followed by concatenation, and the lowest precedence is given to the union operation. For example, for that particular regular expression, you can see that being evaluated this way. Okay, so the star will be evaluated first, followed by the concatenation, and finally the union. I'm going to solidify your understanding of this by showing a couple of examples. In this regular expression, the star operator has the highest precedence, so we expand both the 1 star and then evaluate it from left to right. Clearly, this language has all the possible strings on the alphabet that have a single 0 in them. Similarly, in this example, you would evaluate both the 1 stars followed by the concatenation and then the union. And here is the description for this particular language. It would be the union of the set containing strings that end with 0 and set containing strings made of 1, which also includes the empty string. Okay, so let me review few standard things that I introduced about the languages earlier in terms of regular expressions. Any language represented by the regular expression R concatenated with epsilon is going to result in R. I've mentioned earlier concatenating any language with empty language phi is going to result in phi. On the other hand, R union phi is going to be R, right? So we have a language and then we have empty language. If you take the union of both of them, you're going to end up with the original language. All right, so this one is a little tricky. So R union epsilon will be R if and only if R contains epsilon to begin with. Else, epsilon is this new element that's going to be introduced to the language represented by R. If you apply the star operation on a language twice, it doesn't matter. It's going to just give you the star on that original language. And finally, phi star is epsilon. I'll end this discussion on regular operations by introducing you to the plus operator. It is often used in regular expressions for convenience. Take a look at this example. 0 plus is equivalent to 0 concatenated with 0 star, which is going to end up giving you a language that contains all the elements in 0 star except empty string.